grade 9 learners! It's me, Teacher Johnny, your teacher in Technology and Livelihood Education, grade 9. Welcome and let's learn agriculture and be agri-amazing! For today's video lesson, we're going to discuss select site for planting vegetable crops. This lesson deals with the different factors to consider in selecting the site for planting vegetable crops. It also includes soil system and soil analysis. Our objective is to identify the factors in selecting site for vegetable production. Second, perform soil sampling in the selected site for producing vegetable crops by following the steps in soil sampling. Let's define the following terms. Climate. Climate is the average condition in locality in relation to temperature and moisture. Weather. It is the condition of the atmosphere with reference to its pressure, temperature, moisture, the presence of clouds, and the direction and the velocity of the wind at any given moment. Topography refers to the physical features of the land surface, whether it is sloping, flat level, or hilly mountainous. Factors in selecting a site. In selecting land for agricultural use, look for land with the following characteristics which contribute to its beneficial use. General characteristics of a good farmland. First, the absence of squatters and other prior claimants. Land with titles are preferred. Number 2, accessibility to or easily reached by motor vehicles, railroad, farm vehicles, river transportation, near air and seaports existing or proposed. Number 3, near sources of potable and irrigation waters, near markets or sources of food. Number 5, near schools, churches, and health and medical facilities. Number 6, fertile soil. Number 7, with level or gently rolling topography. Number 8, satisfactory peace and order condition. Number 9, adequate supply of labor, preferably cheap labor as well as skilled laborers or laborers, including tractor operators and mechanics. Other factors to consider in site selection. Number 1, topography of the land. One factor to consider in site selection for vegetable production is the topography of the land. The soil is a vital part of the earth. Without a good soil, no crops could be grown. The picture shows a level land. Students of the Jones Rural School, Jones Isabela, plowing level land using drop carabao. Another picture is a slightly sloping land. Again, a student of the Jones Rural School, Jones Isabela, preparing a slightly sloping land which is best for vegetable production. Water easily drains in a slightly sloping field which is best for vegetable growing. The picture shows a hilly topography of the land. Hilly portion of the land could hardly be reached by irrigation. It is also difficult to till. Irrigation for crops in the hills mainly depends on rainfall. Number 2 factor, nearness to road and transportation facilities. Vegetables are perishable. They are best liked when they are fresh and good quality. If the site is accessible to all forms of transportation, vegetable products are easily transported without much damage. Number 3 factor, availability of water supply. All parts of the plant need water. No plant will survive without water. Water is an essential factor in the production of vegetable crops. Water dissolves plant nutrients in the soil to be supplied to different parts of the plant. Plants can be classified according to their water requirements, such as hydrophytes, mesophytes, and xerophytes. The amount and distribution of rainfall throughout the year also have significant effects on production. For plants grown from seed production, water is vital during the time of fertilization. Number 4 factor, climatic requirements. The climate is mainly governed by temperature, water, and light. There are 3 basic temperatures necessary for the germination and growth of each plant species. First, the minimum temperature limits of the growth of plants. If the temperature goes below the minimum temperature, the plant will not grow or will be stunted. Second, the maximum temperature wherein the plants can still survive. Third, the moderate temperature, which is between the maximum and the minimum temperature, which will make the plants grow fast. Plants which require a cool temperature, like Irish potato, peas, and others, should be planted during the cool season and in mountainous or high places like Baguio and Benguet. Plants like peanuts, eggplant, tomato, and pepper require a high temperature. Temperature affects some vital processes inside the plant like photosynthesis, respiration, absorption of water and minerals, and in the germination of seeds. Enzymes which speed up these processes are affected by temperature. An example is in seed germination. The stored food in the endosperm before the seeds develop should be dissolved in order to be used as food. If the temperature is low or high for the temperature requirement of the enzyme, they will not dissolve the stored food. This is also true in photosynthesis and in plant respiration. If it is too hot, the chlorophyll present in the leaves may be destroyed. That is why you can see burnt portions in leaves during the hot season. On the other hand, when it is cool, the water in the soil gets a bit concentrated and diluted if the temperature is hot. Water and minerals can readily be absorbed if the soil solution is diluted. Water serves as solvent. Nitrogen, phosphorus, potassium, and the other food elements cannot be taken up by the plants unless there is a water in the soil, serving as a solvent for the plant food, which in the form of solution is absorbed by the roots. Water is present in the soil either as free water, as capillary water, or as hygroscopic water. Free water is that which flows under the influence of gravity. This water is not used by the plant. However, it is injurious to certain crops and, for their proper growth, should be removed by drainage. Capillary water is water which adheres to soil particles and is found in the opening between them. This is the water that is of immediate service to the plant. Hygroscopic water exists as a film surrounding and is held firmly by the soil particles. It is only given by the soil particles when these are subjected to a very high temperature. This water is an emergency substitute for capillary water when the latter is not available in the case of severe drought. Light affects the growth of crop plants mainly through affecting, first, their structural development. Number 2, their food production. time required of certain species of varieties to produce seeds. Light is necessary for photosynthesis and is therefore required by green plants for the manufacturing of food. Many plants are influenced by the length of day, especially with regard to flowering, fruiting, and production of seeds. This effect of light is known as photoperiodism. Some plants are known as long-day plants and others as short-day plants. The long-day plants need a comparatively long day for flowering, and their vegetative growth increases when the days are short. The short-day plants such as corn, soybean, and sorghum achieve their vegetative growth when the days are long. They flower and produce seeds when the days are short. Climate is one of the most important factors which control the plant growth and influence crop yield in any given region from year to year. Climate and its relation to crop production. Climate affects crops and crop production. It affects respiration, assimilation, photosynthesis, and other physiological processes in plants. A dry climate favors the growth of vegetative leaf formation. Climate is also important in growing of seedlings and cuttings because moisture favors the development of roots and water is essential for cell growth. Factors affecting climate. First, the latitude. The distance north or south of the equator. As a rule, the further a region is located from the equator, the cooler is its climate. Altitude. An elevation above sea level. In higher elevation, the temperature is lower than at sea level. Number 3. Mountain ranges. It affects wind and humidity. Number 4. Ocean currents. It affects the temperature of neighboring areas. And number 5. Vegetation. More forests and vegetation are like clouding in a given locale. I hope you understand our lesson. Now let's proceed to activity 1.1. Direction. Conduct an ocular inspection of your backyard and select a site for vegetable production based on what you have learned from the lesson. Accomplish the table below which you are going to use by putting a check mark on the space of your choice. Corresponds to how the factors in the site selection for vegetable crops are met. Now let's proceed to the next part of the lesson. Soil. Soil is defined as the loose and friable material of the earth surface for plants to grow. In certain places and under certain conditions, soil consists of two principal layers. A more productive top or surface layer known as surface soil, and a less productive underlayer known as the subsoil. The soil is composed of mineral matter of different sizes of particles known as soil texture, with a small proportion of organic life and mixed with decayed animal and vegetable materials. The soil particles are arranged from the surface soil to the parent rock. Such arrangement is called soil profile, soil sampling, and soil analysis. Soil sampling and soil analysis are important to determine the pH level of the soil and the nutrients present in the soil. Results of the soil analysis will be the basis for fertilizer application. Steps on proper soil sampling. First, make a map of the farm showing sampling areas. Let's denote that as SE. Divide the farm into sampling areas. Each sampling areas should be more or less uniform in cropping history, past line, and fertilizer treatments, slope, degree of erosion, and soil texture and color. Number 2 is step. Collect a spot soil samples from each sampling area. In each sampling area, dig 5 to 10 pits and collect sample from each pit. The number of spot soil samples depends on the size of the sampling area. Spot sample is taken in the following manner. Letter A. Before digging the pit, clear the soil surface of litters and vegetation. B. Using a spade or shovel, dig a pit to a depth of 20 to 30 cm or about 1 pit. Letter C. From one vertical side of the pit, take a slice of soil 2 to 3 centimeters thick with a single downward thrust of the spade. Using a knife or a trowel, trim the slice of soil on both sides to a bar of 3 to 4 cm width. Letter D. Place this bar of soil representing one spot soil sample in a pail or any suitable, clean container. Next step. If the subsoil sample is needed, take a bar of soil from the succeeding 20 to 30 cm soil depth. The subsoil and the surface sample should be placed in separate containers. Next step. Cover the pit and remove the another spot. Number 3. Take composite soil sample. After collecting all the spot soil samples of a particular sampling area, pulverize as you mix them thoroughly. Remove the stones and fresh leaves. Then air dry the soil samples. Place the composite soil sample that is about half kilogram in a clean plastic bag. After that, the composite soil sample which represents the soil of the sampling areas is now ready for chemical analysis. This may also be sent to a soil testing laboratory with pertinent label and information. Let's proceed to activity number 2. Now it's your time to perform soil sampling in the selected site for producing vegetable crops by following the steps in soil sampling as follows. First, before digging the pit, clear the soil surface of litters and vegetation. Next, using a spade or shovel, dig a pit to a depth of 20 to 30 centimeters. From one vertical side of the pit, take a slice of soil 2 to 3 centimeters thick with a single downward thrust of the spade. Using a knife or trowel, trim the slice of soil on both sides to a bar 3 to 4 centimeter width. Letter D. Place this bar of soil representing one spot soil sample in a pail or any suitable clean container. If the subsoil sample is needed, take a bar of soil from succeeding 20 to 30 cm soil depth. The subsoil and surface samples should be placed in separate containers. And lastly, cover the pit and move to another spot. Now let's proceed to the self-check. Answer the following questions. Write the letter of your answer in your answer sheet. that's all for today. I hope you learned a lot in our discussion. This is your teacher Johnny F. Reyes, your teacher in agriculture. Goodbye.
Good day, grade 10 learners! It's me, Teacher Johnny, your teacher in Technology and Livelihood Education 10. Welcome and let's learn agriculture and be agri-amazing. In this video lesson, we will discuss the components of growing media. It includes gathering, mixing, and sterilizing the soil that will ensure the success of growing seedlings. At the end of this video lesson, you are expected to use appropriate materials or tools in gathering and mixing growing media. Number 2, mix components of growing media thoroughly following the correct ratio and proportion. One of the important factors to consider in growing seedlings or fruit-bearing crops is the preparation of growing media. Just like the vegetable seeds, fruit-bearing crop seeds need the same attention in the preparation of the media where they are to be germinated. A successful fruit crop grower must gather the soil media and mix them thoroughly before they are placed in seed beds, seed boxes, or in individual plastic bags. The components of growing media and their proportions are 1 part loam soil plus 1 part of composted manure plus 1 part rice hull or quarry dust or sawdust equals ideal soil mixture. Another composition would be 1 part clay soil plus 2 parts of composted mixture plus 1 part rice hull. And that would be equal to an ideal soil mixture. After the components are mixed thoroughly, the growing media should be sterilized. Sterilization could be done by burning organic materials above the soil. Another, pouring boiling water into the soil. Third, roasting the media using hot cut drum with set fire under it. And you can use also chemicals like formaldehyde at the concentration of 3 to 5 tablespoons per gallon of water and drenching the media in the solution. After the soil media is sterilized, it is ready to be placed in seed beds, seed boxes, or in the individual plastic bags. How to place the soil media in the seed bags? First, put a small flat stones on the top of each hole at the bottom of the seed bags. Fill 1/2 of the seed bags with coarse sterilized soil. Level and press the surface a little bit. And place the fine sterilized soil on the surface. Fill up to about 3 centimeters below the edge of the seed bags. 5. Level the surface and press the soil again. The same procedure is followed in filling the individual plastic bags, except the first procedure. To check whether you learned from this episode, it's now your time to answer the following questions in your answer sheet. Number 1. What are the components of growing media and their proper ratio and proportion? Number 2. Why do we need to sterilize the growing media? Okay, you may write your answers in a sheet of paper and submit your answer sheet when the teacher tells you to submit it. Okay, let's apply what we have learned in this performance task. Let's have the activity. Let's have the title, My Growing Media. Direction. As part of your project, gather one pair or something but that is 10-liter pail of each of the different components of growing media and mix thoroughly. You will use the mixed media in your seedbed, seed boxes, or individual pots. Put the mixed growing media in the individual containers or polyethylene bags for seedlings. Refer to the scoring rubric in the module page 33. Take pictures and create picture collage of the step-by-step process in preparing growing media. Don't forget to put your name, grade, and section, the title of the activity, My Growing Media, and send it to your teacher through FB Messenger or any available platforms. That's all for now. It's your time to answer the 2 questions and perform the task for this week. Keep safe, everyone. Bye!